let's see if we can get the bottom of this page done all in one video here. So a car is traveling at 11 meters per second, that's my velocity, with a momentum, it's P, of 7,150 kilogram meters per second. What's the car's mass? Our mass is equal to P over V. So that's 7,150 kilogram meters per second over 11 meters per second. And that ends up giving me 650 kilograms as my answer. All right, B, if the car slams on its brakes and slows to 4 meters per second, so V1 we said was 11 meters per second, V2 is 4 meters per second. What is its change in momentum? So my change in momentum is M times V2 minus V1. So that is going to be 650 kilograms times V2, which is 4 meters per second, minus V1, which is 11 meters per second. And so that's going to give us a negative number. So my change in momentum is going to be negative 4550, and that would be kilogram meters per second. All right, that's number 5. Number 6, a motorcycle is traveling at 30 meters per second and slows to 16. So V1 is 30 meters per second. V2 is equal to 16 meters per second. If the motorcycle's change in momentum, so delta P is equal to negative 3,500 kilogram meters per second. Calculate its mass. All right, so mass we know is equal to change in momentum over change in velocity. So we already know our number in delta P, but this is going to be V2 minus V1. So negative 3,500 kilogram meters per second over V2 was 16 meters per second minus 30 meters per second. When you put this in your calculator, please, please, please make sure that you remember the parentheses, because otherwise what it'll do is it'll divide 3,500 by 16, and then the whole thing will subtract 30. So you don't want to mess that up on your calculator. So keep those in parentheses. By the time you finish all of that, we should have a negative number on the bottom, negative on top. So we end up with 250 kilograms as our mass. All right, let's look at number 7. Over a period of 35 seconds, that's my change in time. Now, how do I know what all these things are? I'm looking for my units as my clues. A constant force of 13 newtons. We don't know if that's positive or negative yet. Is exerted on a moving car. Calculate the impulse applied to the car. Okay, well, it's not giving us any other information. So impulse, right, is equal to our change in momentum, and it's also equal to F delta T. So that's going to be 13 newtons times 35 seconds. And you don't have to, again, you don't have to do SEC. It's just that my S's look like 5s. So I go ahead and do that. And so I end up with 455 Newton seconds. Now notice I changed my units there. You could also say a kilogram meter per second. This is MV. This is F delta T. So it's up to you what you want to use. Both of them are correct. It's just the kilogram meters per second is decomposed, and your Newton seconds is typical for impulse. All right, so we were able to get through the bottom of this page together.